All right. Okay, I'm going to teach you a little bit about something called the molar mass in this lesson. All right, I'm making this lesson right after I just did yesterday's lesson on the mole. Again, I'm changing the way I'm doing my calculations that is different than what I did in my previous videos. So I'm making new videos and I'm doing this with an empty classroom. So yeah, so it's just it's a little different than what you've been listening to. In the last lesson, we talked about what a mole was. All right, we talked about the fact that a mole is really just a large group of little tiny entities, 6.02 times 10 to the 23. And that is Avogadro's number, all right? And so now we want to talk about, well, what's the mass of 1 mole of a substance, okay? So now we're going to talk about masses. In the last lesson, we just talked about numbers of things. We counted things. How many entities? How many moles? So moles and entities, they count things, all right? Now we want to weigh things, because in a chemistry lab, if I want to do a chemical reaction, I am not going to be counting things, because things are usually in liquids, or perhaps they're in powdered solids, or perhaps dissolved in water. So we tend to weigh things out in grams. We use a scale, and we often measure in milliliters. We use graduated cylinders. So right now we want to talk about masses. When we learn about solutions in another unit further down, we will then get into milliliters and how to deal with that. So today is all about masses. And we want to know how heavy, how many grams is in a mole of a substance. Well, to begin with, I'm just going to tell you it, and then I'm going to do a little calculation to show you where it comes from. So, the molar mass. The term molar, notice it's a mole with AR on the end. It just means pertaining to a mole, a molar mass, which means the mass of 1 mole. And you can see there in the statement, and again, you can pause and write however you need to. It is the mass in grams of 1 mole of a substance. Now, this number happens to be the mass for each element is found on the periodic table. What does that statement mean? I'm going to explain that in a moment. We're going to be learning an equation to calculate molar masses later on. And so the symbol that we use in our equations is capital M, molar mass. The unit is grams per mole. Notice it's got that slash, just like in a speed, like kilometers per hour. This is the number of grams that is in each mole of a substance. It is the mass in grams of 1 mole, and therefore it's grams per mole. So what do we mean by this mass for each element is found on the periodic table? Don't write this down. I'm going to do an example that you will never ever do or have to do on a test. This is just for you to prove where the information comes from. So let's find the mass in grams of 1 mole of a substance. Well, the only thing we really know at this point is what 1 mole is. So let's start our calculation with that. Because I know what the mass of 1 entity of carbon is. If I take carbon and I go to my periodic table, I'm going to find that it's 12U. That is the mass of 1 atom of carbon, all right? And I know that. I've taught you that. That's how you get a formula mass. You go to the periodic table, you round to the first digit, the mass is in atomic mass units, and you found the formula mass. But that is a very tiny mass unit. Remember, 1U is equal to 1.66 times 10 to the minus 24 grams. Now that's going to be useful to us, because that means I could try to figure out how many grams 1 atom is. All right, and I could do that. We'll do that in a moment. We'll finish it off with that. But notice we're starting to see connections on where we want to go. We know that 1 carbon has a mass of 12U. We know that 1U is 1.66 times 10 to the minus 24 grams. So we're close. We're able to closely get grams. Instead of having 1 atom of carbon, though, notice it says 1 mole of carbon. So let's figure out how many atoms that is. So remember our triangle. Entities, moles, and Avogadro's number. And I want to find how many atoms are in a mole. So I want to find the entities. Entities is equal to moles times Avogadro's number. Well, I have one mole. Avogadro's number is 6.02 times 10 to the 23 entities per mole. That means I have 6.02 times 10 to the 23 atoms of carbon. Well, some of you might already be able to start seeing the connection. If I have that many atoms of carbon, I could figure out how many U's that is, because each atom is 12 U. Well, let's do that calculation. 6.02 times 10, and again, you don't have to write this down, I'm just showing you where it comes from, times 10 to the 23 atoms of carbon times 12 U. So that's going to tell me how many U's, atomic mass units, there are. Well, you know the drill from yesterday's lesson. Let's get the calculator out. 6.02. Remember, don't press times, don't press 10. EXP, 23 times 12 equals 3 significant digits. 7.22 times 10 to the 24 U's of carbon atoms. All right? So that's how heavy a mole is in U. But each U is 1.66 times 10 to the negative 24. So let's substitute that U in for the 1.66 times 10 to the 24. And that should turn the U's into grams. And that's what we want. Now notice the work we're doing just to get the mass of 1 mole. Let's do that calculation. 7.22 times 10 to the 24. Now in the place of U, I'm going to put 1.66 times 10 to the negative 24 grams. That's how much each U is. Let's see how heavy 1 mole of carbon atoms is. I'm going to bring this over here. There's my number. It's already in the calculator. You'll notice that when we do calculations many times, the number is already there, so there's no need to retype it. I just need to press times. 1.66 EXP negative 24. Notice how I have to press the negative first. Equals. Look at that great fraction. We hate the fractions change. 11.99 to 3 significant digits. Notice it becomes 12 grams of carbon in 1 mole. Now, I don't have a handy periodic table to bring up on the screen to show you, but again, if you go to your periodic table, you will see that the mass number on the periodic table is 12. This and this both being 12 is not a coincidence. The mole number, remember yesterday I said it was a special number. That mole number is special because that number of entities of an element will have the same mass that's on the periodic table except in grams. That is super useful to us. It means now whenever I ask you a question like the one on the screen, find the mass in grams of 1 mole of C, you will go to the periodic table, you will find its mass, which I'm now going to call the molar mass. You will write down its value, and its units are now grams per mole. That's the only difference. That's why the mole is special. It was calculated in such a way so that we can now skip thinking about tiny little atomic mass units and entities, and we can think about moles, big groups, and grams. Okay. You will never be asked to do that calculation on a test Because if I now ask you to calculate the molar mass of carbon, you will simply go to the periodic table and get the number off of it and have the unit grams per mole. So now if I asked you to find the molar mass of a substance, we do the same thing we did the other day for formula mass, except we have a different unit. And now we're going to be talking about grams, which are useful. So I'm going to go through a couple of these, but this is a review of the formula mass lesson. Calcium, nitrate. Calcium is 2, nitrate is 1. I'm now checking my periodic table. I suggest that you pause at this point in time and get the masses yourself and then complete it and then start the video again. I'm going to proceed. 16.0 times. Remember, there's 6. 2 times 3 oxygen. Nitrogen is 14.0 times 2. There's 2 times 1 nitrogen. And calcium is 40.1 times 1, which I don't normally write in. I'm not going to do that on my big fancy calculator. I'm just going to run it right now. And I have 164.1, and I hope I didn't screw it up, because that would be terrible, but I'm not going to check it. And if I am wrong, put the right thing. But here's the important part. Now that when you're done doing a molar mass, you need to write grams per mole, all right? Grams per mole. And that's a very important thing. I'll do one more. Ammonium sulfate, see if I can get it right. Ammonium, NH4, sulfate, SO, and I got to check my chart, the 4, SO4. Sulfate is 2, crossing over. Ammonium is 1. Ooh, I don't know sulfur. Got to get my periodic table out. 32.1. There's one of them. 1.0 times 8. And again, 14 times 2. I'm going to run it through my calculator. 16 times 4 plus 32.1 plus 8 plus 14 times 2 equals 132.1. New unit, grams per mole. And speak it in your mind like you're a possessed, I don't know, is there such thing as chemistry zombies? You're a chemistry zombie. Grams per mole. It's important that we think that this is how many grams is in 1 mole. It will help us understand it. All right, so this lesson kind of is broken down into 3 parts. This is the first part. How do we calculate the molar mass using the periodic table? Easy as can be. So at this point, there is the handout, which gives you some extra molar masses. Same handout that we've been doing for the last couple of lessons, also on Google Classroom. All right, there's the answers, okay? And my next slide is going to be on how we can use molar mass to do other calculations. So we're going to get a new formula. But for now, I'm going to break this up into 3 different lessons. So I'm going to stop this one, and I'll start another one.